Hello, welcome back to my channel. Today I'll be going over how to calculate the limiting reactants as well as excess reactants. So here are some definitions that you need to be aware of before calculating using stoichiometry to solve for limiting and excess reactant. So what is a limiting reactant? It's a reactant in a chemical reaction that when the reaction is all done, it's the reactant that's first used up. So when the reaction is fully completed, that is when the reactant is gone first and there's no more product formed. So at some point the reaction fully stops, and then that's how you know that one of the reactants has run out. And then the excess reactant is the reactant that is left over. So think of extra reactant, excess reactant. And then the theoretical yield is basically tied to limiting reactant. So when the reactant that gets run out first, so that the limiting reactant is used up, that is when you have your product being formed, and the term for that is the theoretical yield. So those are the conceptual definitions for these three terms. So I will give you a simple example of an equation where you have, for example, the synthesis of water, and when you make water in a certain amount of grams or a certain amount of moles, one of these two reactants will run out first, and then water stops being produced. Okay, so for example, let's say I have 5 grams of hydrogen and 5 grams of oxygen. When you put oxygen gas, and then when you put them together, when they react, it produces water, but at some point water doesn't continue on being produced. One of these reactants gets run out first due to their masses, and then water stops being formed. So you're going to do two setup equations. So we're going to solve for grams of water. Okay, so we're going to do 5 grams of H2, and we're going to solve for grams of water. So same idea, same concept in the rules that we've done before with mass-to-mass conversions. We know that we have to put the molar mass, so grams of H2 goes on the bottom here, and then the molar mass of hydrogen gas, or H2, is 2.016, and the opposite side is 1 mole of H2. And then when we want to solve for H2O, we need to get to mole of H2O first. So same idea. So mole of H2 goes on the bottom, mole of H2O goes on top. And then we use the coefficients to figure out our numbers there. And then final step, to find our grams, we have mole of H2O. Hold that down here, mole of H2O. So we're simply doing mass-to-mass conversions. And then the molar mass for water is 18.015 over 1 mole. So when you solve for this, you get you should get 44.68 grams of H2O. So theoretically, if this was a limiting reactant, which we don't know yet, we have to solve for O2 first, this would be my product formed. But we need to figure out if oxygen is my limiting or not. So we're going to do the same thing here using 5 grams of O2. And we're going to solve for grams of water. So the only difference is basically this part will stay the same, except the mole ratio and the mass of oxygen, obviously. So the molar mass of oxygen gas, or O2, goes on the bottom, and then 1 mole of O2 goes on top. The next step, you do your mole ratio, 1 mole of O2, because we only have 1 mole of that, and then 2 moles of H2O. So you can already see a difference here. And last step, this very last step, that should stay the same because the grams of water does not change over 1 mole. So when you solve for this, you should get 5.63 grams of water. So we have two possible answers here. So either or, one of these will be my theoretical yield, the maximum amount of product. However, we always have to look at our smaller number. That is our theoretical yield, which comes from my limiting reactant. So between these two answers here, 5.63 grams of H2O, this is my theoretical yield. Again, theoretical yield and limiting reactant go hand in hand. Theoretical yield is the numerical value. The limiting reactant is the reactant that produces that theoretical yield. So my limiting reactant, I'm going to abbreviate that to LR. Limiting reactant is my oxygen gas, which means by default, hydrogen gas, H2, is my excess reactant. That's what's left over, and I'm going to abbreviate that as ER. So what we just solved for here is that if I have 5 grams of hydrogen gas and 5 grams of oxygen gas, and we have to figure out, okay, which one of these two will run out first to produce a specific amount of water. When we solve for these two, I can only produce this much. It stops at 5.63 grams of water. There's no way that I can reach this amount of water. This is why this is my theoretical yield. This is my maximum amount of product that I can produce using this amount that I'm given. Okay? And then I have hydrogen gas, so once we reach this amount of grams of water, water stops being formed, and then hydrogen gas is left over. So that is my excess. So I have this example here where the question is fully written out, and I'm going to show you how to break down the question, but the solving is the exact same as what I've showed you up top. So if 6.3 grams of sulfur reacts with 10 grams of oxygen gas, calculate the theoretical yield, limiting reactant, and excess reactant. So I like to underline what I'm given here to break it down, and then I know that I only have one product to work with, so I have 6.3 grams of this, 10 grams of this, and then I have to figure out what is my maximum product or my theoretical yield that I can produce, and which one of these two is my limiting and which one is my excess. Okay, so we're going to do mass to mass here. So 6.3 grams of sulfur over 1. And then we put the molar mass of sulfur on the bottom. Again, we're matching the units to cancel out. And then 1 mole of sulfur on top. Next up, we do mole ratio. We have 2 moles of sulfur and then 2 moles of SO3. Last step, we do mole of SO3 and then grams of SO3. Again, remember, grams of anything, opposite side, molar mass is always per 1 mole. So the molar mass of SO3 is 80.063. So the setup is done, and you're going to solve for this. So I'll give you a second to solve for the grams of sulfur trioxide. You should get around 15.73 grams of SO3, and you're going to do the same thing now with 10 grams of oxygen gas, and you're going to solve for grams of SO3. So go ahead and pause the video and try to do the mass to mass, same thing, and find the grams of SO3 starting from 10 grams of O2. Okay, so you should have gotten 16.68 grams of SO3. Now they have these two possible answers. Again, the smallest number out of these two will always be my theoretical yield, so that would be 15.73 grams of SO3. That is my theoretical yield. which means that comes from my limiting reactant being sulfur. So my LR is sulfur, and my excess reactant, my ER, is my oxygen gas. So sulfur is the one that's running out in this reaction. And my maximum product to be produced is the 15.73 grams of SO3. Alright, there's one final question I want to share on how questions can be worded differently, but the same work process. So let's say you have this equation here. It is a double replacement reaction. You have multiple products. However, when you read the question very carefully, it does specify which product and what you're actually solving for. So if 5 grams of aluminum sulfite reacts with 4.2 grams of sodium hydroxide, how many moles of aluminum hydroxide are produced? So when you break this down, you have 5 grams of this reactant and then 4.2 grams of this reactant. And then it's asking for how many moles of aluminum hydroxide. So even though you have 2 products here, the previous 2 examples that I shared with you, there was only 1 product, so you only have 1 choice to solve for. These you have 2 choices, but since it specifies which product to solve for, I'm looking at this. I only care about this product right here. So, and it says how many moles. You're going to solve for moles. So you're going to solve grams of aluminum sulfite. Set up like that, and you're going to solve for moles. So it's from grams to moles. And then you have your 4.2 grams of sodium hydroxide. And you're going to solve for moles of aluminum hydroxide. And when it says how many moles are produced, it's basically asking you what is the theoretical yield. And I actually also want you to find the limiting and the excess. So determine limiting and excess reactants. So go ahead and pause the video, solve it on your own, and then play the video once you have completed it to check your work. So you should have gotten these 2 responses. It's pretty dang close with your answers here. But technically, this is slightly smaller. The 0.034 moles of aluminum hydroxide is my theoretical yield, which means my limiting reactant, and this is basically answers the question, how many moles of aluminum hydroxide are produced, is this much, 0.034 moles. It is a tiny bit smaller than this one. And then by default, my limiting reactant would be my aluminum sulfite, and then my excess reactant is my sodium hydroxide. Okay, so that pretty much sums up the calculations and how to work with limiting and excess reactant. I hope this video helped. Thank you for watching and have a great day.